Hello everyone, welcome back. Welcome to our 360 DigiTMG official YouTube channel. Welcome to the Gen AI live session. We are discussing about vector databases. So we'll pick up where we left off last week. Just a quick recap for you. So we're discussing vector databases within Gen AI. So we talked about why to use a vector database, how vector database is better from traditional databases, certain concepts, what are vectors, what are vector spaces, what do you mean by embeddings, distance metrics, similarity measures, and all of that. So we'll move forward. Basically, we talked about what is a vector database, what exactly is a vector. And yes, we have seen these embeddings, how when you give a query, how you get a result, right? Backend, how it converts your images, heavy text data, videos, and all of that into vectors and processes the data. So it helps you in indexing, and we've seen how the retrieval concept is. Why exactly we need to use a vector database, okay? And how distance between vectors is calculated. So let's start with this, right? So how distance between vectors is calculated is you have a lot of different similarity searches, a lot of distance metrics that exist. You have Euclidean, Manhattan, statistical, different databases, different ways of calculating distances. Each scientist has proposed their own formula, mathematical formula, and we apply mostly Euclidean distance is what we commonly use, right? So it's basically distance between two vectors, wherein the sum of the square differences of the corresponding component. So if you have an x component and a y component, differences from one data point to the other is calculated based on those coordinates, right? Okay, there are some additional techniques which are involved for calculating distance apart from the traditional ones. So different techniques will be used to optimize similarity search. So how do I say that one word is similar similar to the other word, right? So when we're converting these into vectors, how do I find out the distance between the two? So there are a couple of methods in this. So you have approximate nearest neighbor search, ANN search, which helps you find the nearest neighbor, wherein there are data points which are closest to the query vector within a certain threshold. So we basically define a particular threshold and whichever query you're asking for. So whatever query that you give to the LLM, based on that, the query vector and the vector inside the database, it will calculate the distance, and the nearest neighbor is what within a particular threshold that we set. That will be the nearest neighbor or nearest similar word we can figure out, right? Then hierarchical navigable small world HNSW graphs. So these are the types of data structures which can be used to efficiently search for these nearest neighbors, especially in high dimensional spaces. So like the name suggests, they're basically hierarchical and navigable. So trying to find out basically the parent word and the root word. So like having a hierarchy, right? So when I say swimming, swimming comes from the root word swim. So this kind of hierarchy it's going to look for and figure out which is the nearest neighbor in high dimensional space. Then we have product quantization, PQ technique. This is used to quantize a vector, which exactly means that we are breaking down this vector and representing this huge vector into small number of bits. So it's like splitting the data, splitting a big word into a small word, something like that. Imagine a huge vector being split into small pieces. And then this will basically, when you split it into small bits, it makes the similarity search much faster and easier. But yes, this can basically impact the accuracy as well. So in turn, it can have an impact on accuracy. Okay, what exactly is an embedding model, right? So in vector databases, you have different types of embedding model. Basically, an embedding model is nothing but a machine learning model. It's going to convert any raw data, okay, into vectors. So any words, any text documents, rich text documents, web URL content, okay, any textual data, heavy textual data, it's going to take this raw data and convert it into vectors. So that's what an embedding model does. Okay, these are also known as vector representations or also called as vector embeddings because they're nothing but basically they're going to form a multidimensional array of numbers, and there'll be a specific meaning to each of those numbers, right? So that's exactly how you convert a vector. So in the previous session we discussed, right, how vector is different from an array. What are like we went back to a little bit of mathematics and talked about what exactly two-dimensional vectors are, n-dimensional vectors are, n-dimensional arrays and all that. So in that context, when we convert a raw data into embeddings, which is nothing but your vectors at the end of the day, each of these vectors, some number assigned to that will capture some kind of meaning from the data. So these embedding models are basically trained on huge amounts of data, and they will eventually learn how to map similar words or similar data points, okay, in within that space. So if you have a huge dimensional space, they're going to understand which words are similar to the other words, which input is similar to the other words. Based on those numbers, those data point numbers, it's going to figure out. So this means that distance between two vectors in the embedding space is a measure of how similar the data points are when they are represented. So if I talk about a couple of words like rage versus cage. So if I convert these two words, rage and cage, into vectors, what basically happens because of the backend vector embedding, the numbers being assigned, it will figure out that A, G, E, these three letters are common in both the words and end up saying that these two words are similar to each other. So that's how this will extract. Then embedding models basically used to enable efficient similarity search. They help you store the data in the form of vectors, embeddings, and you can quickly find the data points which are similar to each other. And at the same point, when you ask for a query, your query is also converted into these vectors and it will start searching for a similar vector, whichever is basically the nearest neighbor, closest vector. So less the distance, okay, closer the vector points are to each other, more similar they are to each other. This is the basic concept, right? So embedding models can be used to generate a lot of different variety of for variety of data types. It can generate vectors like text, data, images, audio files, video files. Okay, for example, you have something called as word-to-vec embedding model, which can generate vector representation of words. While a Siamese network embedding model can use to generate is basically used to generate vector representation of images. So you have different types of embedding models, word-to-vec, Siamese, and all of these. Word-to-vec, as the name suggests, usually used when you have text data, a lot of words, and when you're dealing with images, you can use some embedding models like Siamese. Then you have basically these are very powerful because they're super intelligent in building applications. Okay, they can understand and respond to pretty complex data because at the end of the day, they're converting the entire chunky data into numbers. So that's the reason they're able to comprehend the complex data. And they're becoming increasingly popular because of the amount of unstructured data growing in the world. So we're basically scrolling through, a lot of social media apps, there is X, Instagram, Facebook, different social media apps which are generating a lot of unstructured data, right? A mixture of a variety of images, videos, text files, audio files, all of these being this kind of data being generated at the same place. So this is basically increased the amount of unstructured data overall, and this kind of data to consume this, to handle this kind of data, to store this kind of data, we definitely need a higher technological infrastructure, and that's where embeddings, discussion about embeddings and vector databases comes into place. So yes, conversion of data into embeddings by the embedding model, right? So basically, for text data, like I said, we use Word2Vec, or you can also use Glovi. And then for image data, you have a lot of CNN embedding models like Siamese network and all of that. Then for audio data, you have RN, and you can use recurrent neural networks as compared to conventional neural networks. Then for video data, we usually use 3D CNN. Videos are nothing but sequential images, right? Images in a sequence. If you break that a video down, it's basically nothing but images in a particular sequence. So for image data, you can use a CNN model. And for video data, you can use a 3D CNN embedding model. And if you need a lot of higher accuracy, if it's more important to achieve a better accuracy is what your objective is, Then you can use a more complex embedding models like Siamese network. Otherwise, you can stick to your regular CNN, conventional CNN. And if computational resources are limited, then you will use a simpler embedding model like word to vec. So it depends on the kind of project you're doing, what is the business requirement, what are the budget limitations, etc. And you can go ahead with experimentation. Okay, then going forward to basically converting data into vector embeddings by the embedding model, right? So audio data will be converted into data points like this, and they will form these lines are nothing but connections. So it's like quantization, right? I'm splitting one particular audio file into several vectors. Each vector is basically represented by some number at the back end containing some information. So this is how it will be connected. And you can see how their bits are being quantized. So splitting a huge file into small bits, this is how vector embedding happens. Now, how is this raw data exactly converted into vector embeddings at the backend? So we need to understand how it sort of processes this raw data and converts it into vectors and some meaningful numbers. So the first data would be data pre-processing. First step would be data pre-processing, initial step. You're pre-processing the raw data. You'll make it suitable for embedding generation. So this might involve things like cleaning the data, removing a lot of noise from the data, random noises, okay, random behavior. You're removing all of this. You're normalizing the data, right? Normalization of data is also pretty important. So a lot of cleaning, data pre-processing steps, regular data pre-processing steps that involve. Then the next step, which is tokenization, right? So splitting. So basically for text data especially, you are going to tokenize the text. You are going to split the data, text into smaller units, okay, smaller words, phrases, and sentences. So if I give you a huge chunky text file, you're going to split it into small words and phrases and all that. So this will allow the embedding model to place focus on each of the word and phrase, and it will start forming relationship between one and the other. So the entire, rather than looking at the entire document at once, reading it word by word, right? Then you have next step is basically embedding generation. So embedding generation is a step where the raw data will be transformed into vectors. And this is typically done using some neural network models. Again, your word to vect, Glove, all these models will come into picture. They are highly trained on large corpus text data, and they will represent words and phrases as vectors in a high dimensional space. So these word to vec, Glove model and all this, they were basically trained initially on a lot of bulky text data. That's the reason they're able to recognize the kind of text data that we want to feed it with and sort of already know how to split the data. Then comes your dimensionality reduction, definitely, because unstructured data is a very huge data, high dimension data. So we need to talk about PCA, right? Principal component analysis factor here. So vectors generated in the previous step are typically very high dimensional. So how can we make this computation less expensive and all of that? Because to store that high dimension data itself is a big task, and to manipulate the data is another big task. So how do we deal with this, right? So to deal with such kind of things, discrepancies, we opt a dimensionality reduction technique such as principal component analysis can be used, and PCA can be used to reduce the number of dimensions. At the same time, we are not compromising on the sort of information, right? So we bring down the information to a very crisp format, and like sort of compressing the information. So information is not lost, and at the same time, your dimension is reduced. That's what we aim at by doing PCA. Then you have another step, which is indexing. So once the embeddings have been generated, okay, they need to start with they need to be indexed, right? They need to be assigned a proper index so that they can be efficiently searched for. So a lot of databases, especially if you've learned about SQL databases, SQL language based databases. Usually what happens, indexing quickly allows you to save time. It saves the computational energy because indexing is going to help you pick the desired content easily. So that's what indexing is doing within high dimensional embeddings as well. So vector databases will use a variety of indexing techniques. There are tree-based indexes, inverted indexes, okay, different kind of things which allow you to quickly retrieve data. That's the whole point, right? Because you're dealing with such a huge data set, high dimensional data set, that searching for a particular word or searching for a particular vector becomes challenging. So that's where indexing comes into place. Different techniques can be used, and this will basically allow us to quickly calculate distance between two vectors. Okay. Then we have vector databases versus vector libraries. So you have a lot of libraries also into play in the market. You also have a lot of databases in the market. So what is the purpose of a database, right? Specialized storage systems which are optimized for managing and querying large collections of high dimensional vectors. So basically, basic purpose of a database is to allow you to store the data, manage that high dimensional data, and sort of query from it, right? You'll be able to extract whatever you need. So that is what your vector databases will do. For example, Pinecone, Milvus, VV8, Vespa, open source, these are all certain vector databases that you can implement, you can use. Then you have a lot of vector libraries. Vector libraries are basically standalone libraries which allow you for vector searching functionality, and they're integrated into existing applications or database. So if I have already a database to begin with, okay, a base database or an existing application to begin with, and I just want to incorporate this embedding and similarity search using vector embeddings into this, that is when I will opt for a library. Okay. For example, you have a lot of libraries like FAISS, HNSW, lib, NOI, NMSLIB, scan. Okay. These kind of different libraries are there which can be used. So it is very important to understand when to use a vector database versus when to use a library. Database is ideal for production environment which have large, huge dynamic data sets. Dynamic in the sense where data keeps changing, right? So there is a lot of uncertainty in the data, vulnerability in the data. That's when you will go for vector databases. And this vector databases can also be used when you have high demanding performance. That means speed is the more priority. That's when you will go for a vector database. So to quickly retrieve the answer, if that's more important, then vector databases are used. Vector libraries are used when you have a smaller database, smaller use cases, small scale use cases, where you're exactly only looking for a particular, let's say you're working on a legal domain and you have fed only the documents about legal or the legal documents to that particular database. It has only legal knowledge where the use case is limited, right? In those kind of places, you can opt for a vector library, and it will basically integrate into the existing systems. So it's your choice, and depending on the kind of application and the kind of uh, implementation you want to do, you can go for either database or a library. Okay. Now there is Elasticsearch database. Was built by Elasticsearch was basically built by Elastic Corporation. Okay, this Elasticsearch vector database is a feature which is added to. It's not just a feature that is added to an Elasticsearch, but rather a separate product within the Elasticsearch family. It is designed especially for storing, managing, and searching for these vector databases. It's the most downloaded vector database in the entire world. So that's Elastic Search database, most popular. Then you have FAISS Vector Library, which is Facebook AI Similarity Search. Again, this was developed by Facebook AI Research, and it's a library. It's not a database. This is a library which enables you, the developers, in order to search similar multimedia document embeddings. And it is an efficient and versatile library which allows you for similarity search and also clustering dense vectors. Okay, and you have a lot of indexing structures over here. Indexing options are huge, so that will allow you for picking up speed and all that. And yes, this library will support GPU acceleration. So if you have any limitations, system limitations and all that, you can encounter this, right? Because GPU acceleration is acceptable. Then this will enhance the performance for large data sets. Then FAISS basically employs quantization techniques for memory efficient storage and search. So splitting your data into small bits, that's going to help you out, okay? To install this FAISS library, use pip install FAISS CPU command for the latest version, right? So you can install this in your Conda prompt or yeah, basically you can install this and go ahead with using this library. So these are the few installation steps. So first you create a new environment using Python command. Conda create namespace environment underscore names. You can just go to your Conda prompt or directly your command prompt and type like this. Create a new environment. Second step, to activate that environment, you need to use Conda activate followed by the name of the environment. Third step would be to install FAISS package on Windows CPU machine using the Python command. So using Python command, you need to install this pip install FAISS-CPU. So once you successfully complete these three steps, so basically creating a new environment in the first place, and then activating the new environment, and within this activated new environment, you're going to install your FAISS vector library package. Okay. Now, different key features of this FAISS, right? Facebook AI similarity search. It's an efficient similarity search because it offers you a lot of plethora of algorithms, okay? Especially for ANN, approximate nearest neighbor search. So it makes it very interesting. It will allow you to use L2 distance, which is nothing but Euclidean distance, allow you to use cosine similarity logic or inner product logic. So a number of different logics you can apply using this FAISS library. Then obviously you can handle data sets of billions of vectors. Huge, humongous amount of vectors can be taken up and be applied using this library. Then yes, GPU acceleration, it leverages GPUs for significant performance, boosts in search and training. So GPUs will really help us in, improving the speed of the algorithm of the database itself, right? Of the library itself and proceed further. Then compression, we can use techniques like product quantization where you're splitting your vector into small bits and inverted indices, IVF, to reduce the memory footprint and speed up search. So the less memory any application occupies, the faster it is to process it, right? So that's how it works. It allows you to compress using certain techniques. Then you can do a lot of clustering. So it includes algorithms like k-means clustering, hierarchical clustering, in order to organize the data, store it in a good hierarchical way or similar way. So for similarity, also this clustering or grouping will happen at the back end. Languages, it is available as a C++ library with Python bindings, and it's accessible to a wide range of developers. So even with C++, you can use this particular library. Then integration and limitations of this FAISS, Facebook AI similarity search vector library. It can be integrated into existing applications and databases to provide vector search capabilities, obviously. It is used as a building block in the vector databases and search engines. So it really helps out when you already have an existing database in the first place or existing application in the first place. It will allow you to build blocks in the vector database and search for a lot of engines. Okay. Then limitations. It's not a full-fledged vector database, it's just a vector library. So it will lack the features like persistence, management of data, how to optimize a query. All these things are missing, right? There is only so much a library can do. That's the reason. Then it requires a lot of more integration effort when compared to some standalone vector database. It's always easier to use a vector database rather than using a library. But again, if you have budget constraints, might as well go with vector libraries. Then you also have Wilvus vector database. Wilvus vector database was created in 2019 again. Entire goal, right? The basis of this was to store, manage the massive data vectors, embedded vectors, and how do we manage them? By giving proper indexing, right? This was generated by deep neural networks and other machine learning models. So that's the gist of Wilvus. It's basically open source and again cloud native vector database. It is designed to store, manage, and perform similarity search on massive amounts of high dimensional data. So when you have high dimensional data, you'll end up with high dimensional vectors, and this is where Wilvus can come into picture and help you out. It excels at handling unstructured data, like you can give images, you can have text, you can have audio files, and much more, which have been transformed into feature vectors through the embedding techniques. You can convert it into feature vector. Then it is optimized for efficient similarity search, allowing you to find semantically similar items with large data sets quickly and accurately. So even if a large data set is given to you, quickly and accurately, it is going to search for, so it is going to perform semantic and similarity search. You will quickly be able to identify which are the similar vector points. What is the workflow of this Milvus vector database, right? So you can take a picture as an input. It can take vector voice messages, audio files as input. It can take a lot of text data as input. It can take, different things, user behavior, anything as input, and generate deep learning models. And post the deep learning models, whatever labels are given, they're being converted into embeddings. So you insert all of this inside. It will create a index. It will allow for, it's basically cloud native orchestration. It's allowing indexing. It will do a lot of filtering. It will allow you to filter the attributes. It will allow you for time travel, right? And it allows you to ultimately store the data, meta storage, stream storage, and blob storage, right? Blob storage. So these kind of storages are available. This is your Milvus workflow database. So this is a vector database, whereas FAISS is a vector library. Okay, what are the key features of Milvus database? So it's blazing fast, much faster, achieves 10 times faster retrieval speed. So precedence is given to the speed or the performance. When compared to traditional databases, super fast. So because of the advanced and indexing algorithms, it will allow you to optimize the extraction and retrieval. So that's why blazing fast. Then you have, then it's basically highly scalable. So it can handle billions and billions and trillions of vectors. Okay. It has more ability to scale horizontally in order to meet growing data and query demands, because each data point will usually, in unstructured data, huge data point will end up having a high dimension, high number of features or attributes, right? So this has the capability, Milvus vector database has the capability of dealing with such kind of data. Then you have cloud native, basically designed for cloud environments. It will allow you with seamless deployment and management across multiple cloud platforms. So that's possible. You can do deployment and you can manage on different cloud platforms. You can do that. Then you have feature-rich things, like basically it will vary. It will offer various similarity search algorithms like IVF, HNSW. Okay, it will support a lot of multiple vector data types, float data type, binary data type, and it will integrate with popular AI frameworks. So it will allow for these kind of things. And AI frameworks, for example, TensorFlow, PyTorch, etc. And it's super easy to use, very friendly API. Very easily it will get integrated into AI applications. So these are the key features of Milvus. What exactly indices and matrices are supported? So we'll see this tomorrow. Next week when we meet back again. So to quickly do a recap, we looked at what are the different techniques, how we can calculate distances, ANN, HSNW graphs, product quantization, and all that. What exactly is an embedding model? How can we convert, different kinds of data, unstructured data into embedding models? And then how raw data is converted, what are the different steps? So there's data pre-processing followed by the tokenization, embedding generation, dimensionality reduction, indexing, how indexing helps, and major difference between what is vector databases and vector libraries. We've seen one example within vector database, which is Milvus database, and one example within vector library, which is FAISSW. So you have Elasticsearch, again a very popular vector database. Then Facebook AI similarity search vector library that we discussed, how to install, etc. Key features, how do we integrate, what are the limitations. Then Milvus vector database, forward, what are the major, how does it work? So the entire workflow of this, and what are the key features, how it is more very important, what all it can do. So let's meet back next weekend and sort of go ahead with what are distance metrics, okay? How Milvus was exactly designed. A lot of different things about vector libraries and vector databases. And at the end of next weekend, let's try to see a quick demo of vector database itself, right? So until then, let's stay tuned. Please stay tuned with me. Let's meet again next week for the next GNAI live session. Thank you, everyone. Thank you for joining. If you like this video, please like, share, and subscribe to official 360 Digital channel. Thank you.